Hello and welcome to Mr. Linford's math course. Today we're going to be continuing our discussion of factoring polynomials, and in this situation we're going to start looking at a type of polynomial we haven't really dealt with before, and that is the binomial. We're going to be looking at factoring down special case binomials, in particular binomials that fit the sum and difference of squareds formulas, as well as the sum and the difference of cubes formulas. Now the first thing that we have to understand are what the terminology squares and cubes signify for us. When we get into the sum and difference of squareds, what we're saying is we are either adding or subtracting squared values. Remember, squared values are values that the square root can be taken of, and they would give you a whole number answer, okay? For example, let's take a look at this problem, 4x squared minus 9. The difference of squareds says that we must be fitting this form, where you have a squared number on the one and you're subtracting another squared number. So, first off, let's identify what's being squared to get us 4x squared. Well, that's a 2x. That's what quantity is being squared to get you 4x squared. And what's being squared to get 9? Well, that's just a 3. Now that we know what a and b are, let's try to see if we can factor this down. Notice that this is still a quadratic polynomial. This is something that can be written as 4x squared plus 0x minus 9. Hey, we can factor this. We can just use the AC method. So let's go ahead and use the AC method, but you know what? I'd like to try the box method first. You might be saying, why on earth would we do the box method? The AC method worked so much nicer for these types of problems where the leading coefficient wasn't a 1. But bear with me. The first solution we get is a 4x squared. The last value we have is a negative 9. We need to think what multiplied together to get us 4x squared, what multiplied to get us 9, and what added to get a 0x. Well, obviously, we're going to have like terms on the diagonal. To get a 0x, these values must have been the same thing. It's just that one of them would have been positive, and one of them would have been negative. So that means that the outside term must have been negative, and the other one must have been positive. So let's see, what could have multiplied to get us a 9? Well, that could have been 3 and 3. What could have multiplied to get us a 4x squared? That could be a 2x and a 2x. Notice that since we picked the same quantities for each of these binomials, we end up with the same values on the inside. It's just one's positive and one's negative. So they cancel. This is the idea of the difference of squareds. When you factor using the difference of squareds, your solution will be 2x minus 3 and 2x plus 3. We've taken the square root of the first term and the square root of the last term. So if I had the formula a squared minus b squared, the answer is going to be an a and a b, another a and a b, so that they produce the squared values, and then the inside values that we get simply cancel. So the formula a squared minus b squared, we can say the solution to that is a plus b times a minus b. We're creating a situation where we're squaring the first and the last values, and we're forcing the inner values to cancel out. So this is a shortcut formula that you can use. Again, we could have just used the box method here to reason this out, or you could use the AC method. The AC method would give you the exact same solution of 2x minus 3, 2x plus 3. But this is a very special shortcut formula we can use. And in fact, we will be using this later on at a couple random times throughout the course where we can have this understanding of what a difference of squareds is and how it works. Now let's take a look at the sum of squareds. In this situation, the formula is identical, except now I'm adding terms together. So let me do an example, just like before. 4x squared plus 9. In this situation, we're going to replicate the exact same process. So I have a 4x squared plus 0x plus 9. I'm going to set up the box method. We're having a 4x squared in the top left. We're going to have a 9 in the bottom right. And then we can say these values must add to 0. So again, what's the only way that these quantities could add to 0? That would be if they cancel out. So what's the only way that they could cancel out? Well, if one of them was positive and one of them was negative, right? So we could say, what times what get you 2x squared? Or I'm sorry, 4x squared. You could say 2x and 2x. And what got you 9? 3 and 3. So we have a negative 6x and a positive 6x, and we would have, oh, wait a minute. This would get things to cancel out, but notice I would end up with a negative 9. The only way to get these middle terms to cancel is if one's positive and one's negative. But for that to happen, I would end up with a negative 9. That's an issue. That doesn't work out. It turns out the sum of squareds is going to be prime. Again, we're going to say this is prime in the integers, but it's going to be prime for us, okay? We are not going to be able to factor the sum of squareds. When we get to complex units and complex number system, we will be able to factor this. But for right now, it's not going to work with our standard number system. It's going to be prime. And the big reason is that when you set up the box method, you want this value to be positive. But if you want the middle terms to cancel, one has to be positive and one has to be negative. That's not possible here. It's not going to work. Hopefully you're able to see that, and hopefully you're okay with these two, I guess you could call them formulas. The first one being a squared minus b squared gives you the breakdown a plus ba minus b. And then the next one for a squared plus b squared is just prime. Now, with these formulas written down, let's go ahead and move on to another situation where we can hopefully discover other formulas. Here we have the sum and difference of cubes. So it's important to remember cubes are values that have a cube root. Cubes mean we took a number and cubed it to get some other value. So let's take a look here with this example problem of x cubed plus 27, and let's try to decide what number we've cubed to get each of these terms, or what values we've cubed to get each of the terms. So what did I cube to get x cubed? Hopefully you're just saying, well, that's x. And then what value did we cube to get 27? So what cubed gets us 27? That's 3. So in this case, we found a to be x and b to be 3. A is x and b is 3. Here is the general formula we're working with. A cubed plus b cubed. If you have a cubed value plus another cubed value. Well, I'm going to give you the formula in this case. The formula we're going to use, it's a little more complicated, but hopefully you'll start seeing a pattern between the sum and the difference. So if I have a cubed plus b cubed, two cubed numbers added together, the formula for their factors begins with a plus b. Then it goes to an a squared minus an a times b plus a b squared. Okay? This is the format that we're going to work with. This is our formula. All you have to do is figure out what's a and b, and then you can plug it into the formula. So in this case, x cubed plus 27, I know that a is x and b is 3. So to factor this, I have x plus 3. Then I can take x and square it. I can subtract x times 3, which is 3x. And then I can add 3 squared, which is 9. This is going to be the breakdown, okay? These are the factors. Couple things you'll notice about this. The factors are not two binomials, which is fine. We're not dealing with quadratics here. We're actually dealing with a cubic. So I don't expect it to be two binomials. All that you have to do in this case, figure out what a and b are, and then plug it into the formula, okay? Let's now take a look at the formula for the difference of cubes. It's going to be similar to the sum of cubes, except in this case, the signs will be a little different. Instead of a plus b, we have a minus b. Then we're going to square the a, and we're going to add it now to a times b. And then we're also going to add on the b squared. Notice the difference in these formulas. Really, the only difference is the signs. And in fact, let's see what signs are different. The initial sign here is different. And then the sign in the trinomial that you have is different. The b squareds are always just added together, so those aren't any different. Notice how it's related to what you started with. What we're going to do for this situation is really try to work with the acronym SOAP, or what's sometimes referred to as the SOAP technique. SOAP is an acronym, S-O-A-P. What it stands for is same, opposite, always, positive. SOAP is an acronym that's supposed to help us determine what the signs are going to be. So, in the situation where we had the sum of cubes, the signs go as such. The first sign is the same. The second sign is the opposite of what you're working with. And then the last sign is always positive. Let's see how this works now for the difference of cubes. Here we're taking a difference, so the first sign is the same. The second sign is the opposite of what you're working with, so it's plus. And then the last one is, again, always positive. This technique, this SOAP acronym, can sometimes be helpful when you're trying to memorize how do the signs fit together. The unfortunate thing is with this, you will have to memorize how this format goes, because this is going to be the general technique that you're going to fit your solutions into. So let's practice now using this formula for the difference of cubes. Here, A is going to be x, and B, let's see, what cubed got us 8? Well, that's just a 2. You don't need to worry about signs because the formula already takes signs into consideration. So, if A is x, we're going to subtract the 2, which is b. I'm going to square the x, and then I'll add on the 2 times the x, and then I'll add on the 2 squared, which is 4. This is the factorization. This is how we've gone and broken down the factors. We're just using the formulas. The reason I don't need to take the signs into consideration is because we have an algorithm, a formula to tell us what to do, I should say. Before, we didn't have a formula. We just had a process for how we were reasoning things through. Here, the formula takes the signs into consideration, okay? So, make sure that you're comfortable with each of these two formulas. Make sure that you have them memorized down, because we're going to use them to simplify binomials. For example, let's take a look at these 3 practice problems. What I want you to do is first identify, are you dealing with a sum or a difference of squares or cubes? That's the first thing that you have to identify. Then, try to see if you can figure out what a and b are. And once you know that, try to see if you can plug it into the appropriate formula. So pause the video, take a minute, and I want us to first figure out, are we dealing with a sum or difference of squares or a sum or difference of cubes? Once you decide that, try and figure out what a and b are. And then we'll check back in just a moment. All right, well, hopefully you're recognizing that some of these are going to be squares and some of these are going to be cubes. Obviously, in the first problem, we're dealing with squared quantities, because look at the exponent. It's a 2, right? Most of the time, the exponent's going to tell you if you're dealing with squares or cubes. So I try to say, okay, what squared got me x squared? Well, x. And what squared got me 25y squared? Well, that would have been 5y. So I figured out what a and b are. Similar to the second problem, since I'm dealing with cubes and a sum, I have the sum of cubes. So I know which formula I'm going to work with. This time I got to decide what's my a and what's my b. So what cubed got me 8a cubed? Well, that was 2 and an a. And what got me 27b cubed? Well, that was a 3 and a b. Now the last problem seems a little trickier. X to the 6 minus 64. Well, I'm looking at 64 and I know that's a perfect square because I can take the square root of 64. It's 8. And I can say x to the 6, what squared got me x to the 6? Well, x cubed did. So here's my a and here's my b. All I'm doing is using properties of exponents to represent x to the 6 as x cubed squared. Now that we know what a and b are, let's go ahead and let's take a minute, plug them into the formulas, and see if we come up with the correct solutions. Well, as you go and work through these problems, hopefully you'll notice that all we need to simply do is plug things into the formulas. So when I have the difference of squareds, we'll end up with x plus 5y and x minus 5y. The difference of squareds is really where you have the same binomial twice, it's just one's positive and one's negative. Remember, we want to cancel out those middle terms in the box method. For the cubes problem, again, just plugged it into the formula, and we're making sure that our signs, since it's a positive, it starts positive, then goes negative, and then goes back to positive. You will notice that I simplified because I said a is 2a, I have to square that to get 4a squared. And I had to square the 3b to get 9b squared. So make sure that you're doing that when it comes to this formula. And then for the last one, I used the difference of squareds, and I got an x cubed minus 8 and an x cubed plus 8. Again, the same binomial twice, it's just one's positive and one's negative. Oh no. As I look at this answer, I'm realizing something. X cubed minus 8 and x cubed plus 8. Take a look at that solution and ask yourself, what is it about that answer that's making me worry a little bit? What do you see there? Well, hopefully you're noticing that both of these problems are cubic. And in fact, this is the difference of cubes, and that's going to be the sum of cubes. So it turns out we can actually keep breaking this down further. Always double check your final solution, because guess what? Sometimes they can continue to be simplified, actually in quite a lot of the cases. So I'm going to switch up colors here. I'm going to go to red, and let's try to break this down a little more. I'm going to break down the x cubed minus 8 first. A in this problem is x, and b is going to be 2, because what cubed gets me x cubed? Well, x. And what cubed gets me 8? 2. So that's the first one. We are going to end up with an x minus 2 times an x squared plus 2x plus 4. Okay? That's what happens when I broke down the x cubed minus 8. I had the a minus b, I had the a squared plus a times b plus b squared. Now I'm going to break down the sum of cubes in this problem using green. Again, a here is just x, and b is just a 2. So we end up with x plus 2, and then we have, oh, looks like I'm running out of room. I'll just move down here. X squared minus 2x plus 4. Looks a little messy. Hopefully you can see both of these are identical to each other. The only thing different are the signs. Now, if you wanted, you could leave your answer pretty much just like this. And that is going to be the full factorization. We've gone through and we broke it down using the difference of squareds, but then we saw our factors were still cubics. So we could break those down further using our formulas. Now, some people actually thought about doing this problem a little differently. Let me clear some space here, and let me rework this problem for us. You'll notice that I started by taking the difference of squareds, because for me, I went and saw that 64 is a squared number. I know that for a fact. It's 8 squared. But 64 is also a cubed number. I could say, what number cubed got me x to the 6? That would have been x squared. And what number cubed got me 64? That would have been a 4. So what we could have done was say, okay, a is x squared and b is 4. So we can plug it into the formula to get x squared minus 4 times, well, let's see, we would have x squared squared is x to the 4th plus 4x squared plus 16. And we could keep breaking this down further. So the point I want you to understand is that sometimes in a situation like this, we could start in either way. But we just have to keep checking our solutions and what we end up with to realize that we might be able to still break down our answers even further. So make sure as you break down your solutions, you keep checking your work to make sure that you can go further and further each time. If you have any questions about this video, please let me know. My email is klinford, that's KLINFORD, at wccnet.edu. Let me know if you have any questions or comments, and until next time, take care.